addColumns is an iterator and a table function. It receives first the first argument that needs to be a table. addColumns returns the full table. Then, during the iteration, it can create new columns. For each column that you want to add to the output, you need to provide both the name of the column and the expression. The expression is evaluated in the row context during the iteration. And that is why if you want to create a filter context out of the row context, you need to rely on context transition and use calculate in order to compute your numbers. Let's see that with a couple of examples. You see that we are using in this query addColumns that iterate over the values of the calendar year. So for each year, addColumns evaluates the further arguments. We provide a name and then an expression that is evaluated in the row context of addColumns. This is why you can reference date, calendar, year, as we are doing here, to extract the value of a specific column. The first column, year number, only returns the digits of the year. The second column, amount, computes the sales amount. It is calling a measure, therefore calculate is there, context transition is happening, and the sales amount is the sales amount of the given year. If you look at quantity wrong and quantity correct, you see the need to use context transition. In quantity wrong, we are only computing sum of sales quantity. No context transition is happening, therefore, because we only have a row context, the value returned is the grand total of all quantities. If you want addColumns to compute a value in a filter context, you need to rely on calculate, as we are doing here, to compute the quantity correct. One important note about addColumns is about the data lineage. addColumns does not keep the data lineage of the new columns that it creates. So any new column that is generated by addColumns, even though it is only a reference to one column, does not maintain the old lineage. It creates always a new lineage. The example is kind of tricky, so we need to follow it closely. Here I'm defining a first variable, year and year numbers, that uses addColumn to add to the values of the calendar year a new column, year number, which is the same as date, calendar, year, and the sales based on the year, which is using context transition and computes the sales amount. The result is the calendar year, the year number, and then the sales based on the year. The sales based on the year represent the sales of the given year because of context transition. The next step that I want to do is to get rid of the first column, calendar year, because the first column coming from the calendar year has the correct lineage. It is a year. The second column contains the very same value, but addColumns will have created a new lineage, so it is not a calendar year. This is what is happening in the second variable. Year numbers uses select columns to select from this table only the year number and the sales based on year. So I'm getting rid of the first column, and you see the result here. It only contains year number and sales based on year, which has not been recomputed because it was computed earlier. In the last step, I iterate over this table containing the year number and the sales based on year, and I compute again sales amount using context transition. Now, this context transition should filter the year because we have a year number, but because addColumns did not keep a lineage, it created a new lineage. As you see in the result, the sales based on year number computed in result contains always the grand total of sales. And the reason is addColumns did not maintain the lineage, which is different than many other DAX functions that keep the lineage if you're using a simple expression.